So this video is going to tell you guys how to know if two triangles are similar. And the two ways you tell are by looking at the angles or by seeing if the sides are proportional. Step one, you're going to check the angles. If all you get are angle measurements, they have to be congruent. Do you guys know what congruent means?
Yeah. Here's the bug.
Yes.
Wait, that means
Okay, what does congruent mean exactly?
same size, same shape. Cool, this is what.
All right, so if you look at the sides of a triangle, proportional means it has to use the same scale factor. Like one triangle would have to be multiplied all by 2, or one triangle would all have to be divided by 3, or something like that. Question 1 on your paper says, explain whether these two triangles are similar. If you notice, this one has angle measurements, but one is missing. So we need to figure out what that one missing angle is, and then we can tell if they are similar or not, because all the angles will be congruent. Does anybody know how to find a missing angle in a triangle?
What you do is you add up the sides, and then when you get the answer, you subtract it from 180.
Okay, great. So in the first triangle, I have 88 plus 42. Do you guys agree that's 130?
Yes.
Okay, then she said take 180 and subtract it from 130. Do you guys agree that's 50?
Yes.
All right, so I'm going to put a 50 right there. I'm going to have to check the second triangle, so I'm going to look at 88 plus 50. How much is that?
138.
What should you do last?
Subtract it from 180.
And does anybody know what 180 minus 138 is?
52.
Okay, remember you have to borrow.
Oh, wait, 42.
All right, great. So this angle is 42. Are the angles congruent?
Yes.
Yeah.
Okay, so that's what I'm going to say for my answer. Yes, because the angles are congruent. And later, if you see another question like this, you do the same process and then compare all the angles to see if they're exactly the same. If you move down your page, this is question 3, and this one says, the diagram below shows roof trusses. So this would be the shape inside your roof, and if your roof is very steep, or if it's really long, they have to put these extra support beams inside your attic to make sure your roof doesn't fall in. So that's actually what this picture is. And it says we're going to use this diagram to do questions 3 through 5. So later we're going to look at question 4 as well. This question doesn't have angle measurements in it, but it says explain why triangle LQN is similar to triangle MPN. So I'm going to use 2 different colors, and I'm going to trace over the 2 triangles we're looking at. So LQN, I'm going to trace that entire triangle. Then I'm going to trace the second triangle, MPN. For this one, instead of using the angles, I'm going to use the sides. And sometimes it's hard to tell when 2 triangles are overlapping. So if you really did draw them separately, I've got the big orange one. The measurements for the big orange one, the side is 8. So I'm going to put an 8 on the side. And the big one, the bottom, if you go all the way to the end, it's 6 plus 6. How much would that be altogether? So I'm going to label the bottom of the big triangle 12. Then I'm going to draw the small triangle. And right now, the only thing I know about the small triangle is that the bottom is 6. So I'm going to put a 6. So since this side right here isn't actually labeled, I can compare these two bottom measurements to see if it's using the same scale factor. If you want to use the bottom of 12 and turn it into a 6, what would you do? Okay, sometimes you use proportions. So if I said the first triangle was 8 over 12, and I wanted to equal something over 6. Someone just said the scale factor is divide by 2. And then this one is divide by 2.
4.
So the missing number is going to be 4. So it looks like my triangle shrank in half. And if that's really what happened, then I would say they're similar. Another thing you could look at to tell for sure that they're similar, they both have right angles in this corner. So we know these are 90. And they're both actually using N for their bottom right-hand corners. This is letter N, and this is letter N. So technically, their angles are also going to be the same. I've got 90 degrees in this corner. I've got an N. And then smaller one also has 90 degrees plus an N, which would mean the last angle has to be the same. If we look back at the equation, it says explain why they are similar. So in the end, really what I want to say is a sentence. I'm going to say yes, because angles are congruent. Because they both have a 90-degree angle, and they're both using letter N as their other bottom angle. But also, we just figured out that the sides were proportional. And that would give me both reasons for why these two triangles are similar. Question 4 asks us, what is the length of the support beam labeled MP? So I'm going to trace over that little line. And if you remember in the last question, we just figured out what that was. It was the side of the little tiny triangle. And the bottom of it was 6. And we had a question mark. Then the big triangle had 8 for the side, and it had 12 for the bottom. Do you remember what we said the missing part was?
4.
Awesome. So I'm going to say MP equals 4. And if you want to be official, the units are feet. So the final answer would be 4 feet. Oh, crap, I did do it. All right, number 5's on here, so we'll try and figure out 5 as well. 5 wants to know, is it possible, can you tell if triangle LQJ is similar to KRJ? So I'm going to trace over those. LQJ. Then I'm going to trace over RKJ. Once you trace over these two sections that are on the left, they should look exactly like the two questions we did over on this side.
So they're the same exact size, right?
Then they are all the exact same size. So I would still use my same answers. Yes, because angles are congruent. And that would be enough, really, because if the angles are congruent, that's my one way of determining that they are similar. Question 6 has also one triangle overlapping another one. But in this question, it just wants me to find out is when I have side SV and side RW and they're parallel. So that's what these symbols mean. Two little arrows are signaling that these lines are parallel to each other. So it says they're for sure parallel. And then it says, based on that information, if you look at triangle RTW, so I'm going to trace that, RTW, the big one, is it similar to STV? So I'm going to trace that one also. Even though we don't have any angle measurements, we don't have any side measurements, we already talked about when you have two parallel lines and they're cut by a transversal, what would you know about these two angles?
They'll be the same size.
They're cute.
And why are they the same?
Because it makes it cut it in half and move it down.
They fit on top of each other. They are congruent.
They would fit on top of each other because they are corresponding.
They are what? Corresponding.
Corresponding angles are the same, which means in the end, I would have to say yes, they are similar because the angles are congruent. Corresponding angles are congruent, so that would mean my triangles are congruent.
Oh, I thought that's somebody calling me.
If you guys go to the next page, question 8 says, can you assume that the similar triangles, they're already telling us that they're similar, in problem 7 are congruent? So the major part of this is I need to know if they are congruent. I already know they're similar, but just because they're similar, does that also mean overall all the triangles are congruent? And you guys told me congruent means it has to be,
Same size. And shape.
they have to be exactly the same size and the same shape. So just because the angles are the same, does that mean the length of the sides are the same?
No.
So I cannot assume that they are congruent because no side lengths are given. If they did give me the side lengths and they were all the same measurement, then I could go ahead and say they are exactly the same size. All I know is that the angles are the same, but the side lengths don't have to be the same.
Dang it.
Okay, last question we're going to do is very similar to question 3 and 4 and 5 that we already did in this video. It says a tree makes a shadow of 21 feet. So that is the bottom. This is going to be the shadow of the tree. And then it says Enzo is 5 feet tall. So it has 5 feet and it's labeling it with Enzo. It says the Enzo casts a shadow of 6 feet long. So that's why this is labeled 6. And I'm trying to figure out how tall the tree is. It's really hard to measure how tall trees are. So if I draw the big triangle and then I draw the little triangle for the guy, I can label his height as 5, his shadow as 6, like it already is. I can label the big shadow as 21, and I got a question mark right there. I should be able to set it up question mark over 20 is the same as Enzo 5 over 6. Now this one doesn't work out quite as evenly. 21 doesn't magically turn into 6. So in order to do this one, we are going to cross multiply the diagonal numbers. 5 times 21. And that has to be equal to 6 times a number. 5 times 21 is 105. And 6x is still 6x. So your last and final step would be to divide 105 divided by 6. And that's going to tell you the tree height. Keep going. Keep going. You can do it.
Woo! That's my freedom!